papers only look at carbon, but if you're really serious about climate change mitigation, you do have to think of the other greenhouse gases as well, like nitrous oxide and methane, because a little bit of nitrous oxide goes a long way, about 300 times more effective than carbon dioxide in climate warming. So if we don't take those gases into account, then we're going to cause a lot of confusion and maybe undergo some changes which aren't as beneficial. And then when we look at papers and look at the results, we need to think about whether they're as carbon or as carbon dioxide equivalents. And Jerry was presenting us, and indeed the first speaker, with some CO2 equivalent data. And it's sometimes quite difficult to see in the literature exactly what they're talking about, whether it's carbon or whether it's CO2 equivalents. I'll try and define which I mean, but it's not always clear to me. But the other thing to say, of course, is that extra carbon is really good for soil quality. So it's not just climate change that we need to think about and sequestration, but the quality of the soil and its ability, as Jerry was saying, to go on growing crops year after year. And a little bit of carbon going back in can make a huge difference, as we'll see. So the land use changes that I'm going to go through, just very briefly, that might give us some climate change mitigation and carbon sequestration are these. As I say, I've added grassland, thought a little bit about duper rooting plants, but we've got another talk about that later, so I shan't say too much about that. And I'm going to mention dear old biochar. I don't know whether we have any biochar believers in the audience or watching us from overseas. In Britain, we have those who say that biochar is the answer to everything, and we've got others who say, no, it's a complete waste of time, it's not worth looking at. But we will spend a few minutes looking at biochar. So let's start with biosolids, animal manures, human waste, whatever. And we've done some calculations to look at how much of the carbon in biosolids goes back in, is retained in the soil. And it's about 25% on average year after year. That's from manure. The problem is, if you think about that as climate change mitigation,